Hello, my name is Caitlin Green, and this is my vlog for the Chapter 2 textbook questions, Take 2. As you can see here, I do have a blank copy of my notes because I printed off the questions just to make it easier for me to work them out. So what you're seeing is the blank copy. However, I do have my work here, so that's what I'll be using to explain my thought process throughout this vlog. So question 1 is asking about 19 loudspeakers that were tested and measured for efficiencies. So as you can see, everything's already organized, and it's simply asking to compute the mean. And there are 19 numbers, and whenever I add up all 19 numbers, we add them all up and then we divide by the number that are there. So I ended up getting x bar is equal, or the average is equal to 84.95. It then asks, why is this reasonable? And I said that it's reasonable because the numbers range from 73 to 92, as you can see here. So it's not a very wide range of numbers. There's not any extreme outliers or anything like that. And the majority of the data falls in the 80s range. As you can see, from 80 to 89, majority of the numbers are contained in the 80s. So because of this, 84.95 falls right in the middle of the data set, and that makes it a very reasonable mean. Question 2 then asks to find the mode, and the mode's a very easy but unreliable measurement to use, and so we took the mode, computer difficulties. We saw that the number that occurred the most was 82, as you can see 1, 2, 3 times right here. So that was what we found for the mode. Then B asked to using the sorting and counting method to determine the mean. And the sorting and counting method's equation is 2 multiplied by n plus 1 divided by 4. And this makes pretty reasonable sense just because if you're going to find half of the data, you do need to have 2/4 or 1/2 in the equation. So I took 2 and multiplied it by 19 plus 1 because there's 19 speakers, and then divided it by 4, which ends up giving us 40/4, which then shows us that the 10th number is going to be the median. And so whenever we go and look at our data, we can find that 86 right here is going to be the median. And then part C says, compare the median and the mean. And what does this comparison tell you? So as I mentioned before, our average or our mean is 84.95, and then our median that we got is 86. So as you can see, there are 2 different values, which means that the distribution is not going to be normally distributed. And because the mean is less than the median, it means that we are going to get a negatively skewed graph, which is what comparing the mean and the median tells us. Moving on to number 4 through 6, we have to use the data found in the stem and leaf plot to answer the questions. And we don't have to do question 3, but just to go ahead and mention it, the mean of this data is going to be 28.83 because we will need that for one of the questions later on. So it says, by sorting within the critical class, calculate the median by sorting and counting method. And to find the critical class, in which we're trying to find the mean, we take the total numbers, which is going to be 35, and find half of that, in which we find that the number was going to be 17.5. And so now we need to look in our cumulative frequencies to find which which class contains 17.5. As we can see, these first 3 numbers are too small, but right here at 20, does contain 17.5, and so that means that our critical class is going to be 25 through 29. And so knowing that, we then have to find the median address, and like I said earlier, the equation is 2 times n plus 1 divided by 4. And so since there's 35 numbers, we're going to take 2 multiplied by 35 plus 1 divided by 4, and we're going to find out that it is going to be the 18th number in the data set. And these first 3 columns right here, or rows, are going to have the first 12 numbers, which means starting off at 25, we will go 13, 14, 15, 16, 17, and then bam, 18. And so that means that our median is going to be 27. Moving on to question 5, it then asks us to find the 50th percentile of the error distribution in problem 3. And the 50th percentile is another form of the median. However, it is just going to be a little bit more of an accurate description of the median, because it's giving us the true median instead of just the median that's like displayed in the results. So the critical class, as we know before, because we're having to take back an equation from question 2, the critical class is 25 through 29. Which means that the lower real limits of this problem is going to be 24.5. I is going to be 5 because there is a value of 5 in between each class. B is going to give us 34.3, and then K is going to be 22.9. So we're now going to take this into and put it into our percentile to number equation. So it's going to look something like x of 50 is equal to 24.5 plus 5 multiplied by 50 minus 34.5 divided by 22.9. And as you can see, I set up the equation as such. It's a little bit messy, but I think I did my best to make it organized. I'm going to give myself more space next time. But whenever we get everything added up, eventually we're going to get to 24.5 plus 3.4, which gives us an x of 27.9, and the x, of course, of this problem is the median. So moving on to the final question, number 6, it says to compare the mean errors with the median errors. And just to refresh you, the mean of these problems was 28.83. The median was 27, and then the 50th percentile was 27.9. So it then asks, what do these two comparisons tell you about the error distributions? So the mean error is larger than both of the median values found, which means that the data is going to be positively skewed. As I said earlier, if the mean was smaller, it would be negatively skewed. This answer is going to be reasonable as a visual inspection of the error distribution, because the quote-unquote outliers, because they are bigger numbers, but I'm not really sure if you'd call them outliers so much, but the outliers found in the critical class 53 and 51 do stretch out the data quite a bit, because you see that we start at a low number of 10, and really we have a cluster of numbers right up to about here, I believe 38 through 10, and then of course these higher numbers stretch it out quite a bit. But the outliers found in the upper range, like I said, will stretch out the graph, which means that the values of 50 through 54 cause a positive tail to occur on the graph. And that will, once again, like I said, since the mean is larger than both the medians, we will get a positively skewed distribution on the graph when we look at a visual representation. So this has been my vlog for the Chapter 3 textbook problems. Overall, the 3 M's weren't too hard, and I didn't really have too much trouble doing this set of problems. So thank you for watching, and I hope you have a good rest of your day. Thanks.